Welcome back, student. This video clip is prepared for chemical reaction engineering subject. And today I will give the exercise for different types of a reactor in series. So consider two different types of a reactor in series. A CSTR connected to PFR, that means mixed flow reactor, or continuous stirred tank reactor connected to plug flow reactor. There are two ways in which these reactors can be put in series as shown in figure 4.21. So this is the figure 4.21. In scheme 1, the plug flow reactor is connected first and then it is followed by the CSTR. So this is called a scheme 1. And second scheme is CSTR is connected to the plug flow reactor. So here this reactor gives conversion X1 and this reactor gives conversion X2. Then this reactor gives conversion X1 and this reactor gives X2. So which scheme to be used for your given reaction? So there are some points to be considered. If the size of each reactor is fixed, then different final conversion X2 will be obtained depending on whether the CSTR is first or PFR is placed first. And if the intermediate and overall conversions are fixed, then the reactor volume as well as their sum can be different for different arrangement. That means if you fix the reactor's size for final conversion, that will be depend upon whether the CSTR is first or PFR is placed first. Or if the intermediate and overall conversion are fixed, then the reactor volume as well as the sum can be different for different arrangement. What is the meaning of this? So here if we consider the fixed intermediate and final conversion for both the schemes, then volume will be different for both the scheme. So depending upon that, we can consider the perfect scheme for your reaction. So for that purpose, I will give one exercise. You have to solve this exercise. So exercise is that for the reaction data given in the following table, so this is the table given, consider the series arrangement of a mixed flow reactor and plug flow reactor. If the intermediate conversion is 0.7, that means 70%, and final conversion is 0.8, that means 80%, which reactor should be placed first to obtain the smaller reactor volume? And Fa0, that means molar flow rate, is given as is equal to 0.083 moles per second. So this data is given for a certain reaction, and there are two reactors, means mixed flow reactor and a plug flow reactor, and these reactors are to be placed according to your volume. So for that purpose, to solve this exercise, I have given a hint. That means we have to consider first two possible schemes that are given below. So first case is the plug flow reactor followed by mixed flow reactor. So this is known as the figure 4.23 and scheme first. So you have to consider the first plug flow reactor and then it is followed by the mixed flow reactor or CSTR. So here the conversion is 0.7 and here the conversion is 0.8. And then you have to consider second scheme, that is mixed flow reactor is placed here and it is followed by the plug flow reactor. So here the conversion is 0.7 and another conversion is, final conversion is 0.8. So how will you decide this? So for that purpose we have to go through these steps. So first we have to plot 1 upon minus RA versus XA from the given data. So this data is given. So you have to calculate the value of 1 upon minus RA here. And then you have to plot the 1 upon minus RA versus XA. This graph. Then calculate the volume for the scheme A as shown in figure 4.23. So this is the figure 4.23. The first scheme is that you have to calculate the volume of plug flow reactor for the conversion 0 to 0.7 and then from 0.7 to 0.8 for CSTR. And again you have to draw the another graph, and again you have to plot 1 upon minus RA versus XA, and then take the scheme B. So this scheme. So here you have to measure the volume of mixed flow reactor or CSTR from 0 to 0.7 and then 0.7 to 0.8 for plug flow reactor. So after that you have to add this total, means first calculate this volume, then add this and the total volume of this scheme. Then second you have to calculate the volume of CSTR and the plug flow reactor and then make the total. And finally, what is the answer? The answer gives the fourth step. Scheme which give small total volume will be selected for a given reaction. So after calculating the volume for these two schemes, any scheme that will give the smaller volume, that will be considered as an answer for this problem. So solve this problem on a graph and measure the volume of each reactor for both scheme and calculate the total volume for A scheme and B scheme, and then you can give this answer. Thank you.